Hey kids! Okay, we are here in lesson 4 in module 4, and this is a monster lesson, so we're just going to jump right in. No time for dilly-dallying today. The objective, use tape diagrams to model fractions as division. I have a few sample problems in the notes which you really should write down and practice with before you jump into the book. I'm going to talk through them quickly. You can slow the playback speed down if I'm going too fast, but definitely take some good notes so you can understand this concept. Problem 1, if you have 8 tons of gravel and it's divided between 4 dump trucks, how much gravel would be in one truck? So the whole idea of using the tape diagrams to model fractions as division is to recognize what is the whole and how many parts do you have. And so always put that whole labeled up on top and then divide it into the appropriate number of parts. So we have 4 trucks, therefore 4 parts. Now the 2's are not in there just yet because we don't know how much is in there. It's 8 divided by 4. Once you set it up in the way the book wants you to do it, which is so wordy and complicated, it's overcomplicated, honestly, once you get that, you'll figure it out. So essentially it's 8 divided by 4, which is 2. And so this is one truck. So 2 tons per truck. 2, 4, 6, 8 makes 8 tons. Now this whole process of do the division, do the check, it's going to make more sense when we get into fractional units. So then problem 2, 5 tons of gravel. You have a new whole and you still have 4 trucks. So again, 4 pieces to your tape diagram, but a new total. Okay, so it's 5 divided by 4. This is how you're going to set up the straight division. Then you're going to do the division. It's just a real simple, we're not annexing a decimal with zeros. We're just going to stop with the remainder, put it in a fraction. This is the answer, okay? But of course, that's not what they want. They want a little bit more information. And so this part here on these is looking at how many parts there are, okay? So we have 4 units in both problems. But in the first one, 4 units equals 8 tons. And in the second one, 4 units equals 5 tons. And so the amount can change. This is the total. But what we're looking for in both is how much is in 1 unit. So you set it up with the division, 8 divided by 4 or 5 divided by 4. So you're modeling that formula. And then once you get the answer, that's what 1 unit is worth. Here it's 1 1/4, here it's 2. You also have to check. You're checking your division with multiplication. When you get a quotient, it's the quotient times the divisor. So 4 times 1 1/4. But because we haven't started multiplying yet, we're checking by repeatedly adding. Okay? Here you can multiply whole numbers. That's fine. But not with fractions and mixed numbers. Not yet. Okay? So when you add these 1, 2, 3, 4, and then 1, 2, 3, 4 on the numerators, that comes out to 5. And then always check and make sure that what you get equals the whole that is being shared. More problems on the back. A 3-meter ribbon cut into 4 equal pieces. What is the length of each piece? And again, 3 is the whole. 3 is the whole. 4 pieces. 1, 2, 3, 4. 3 divided by 4. But this is not a bigger number. It's a smaller number. And so when you can't divide, what you end up with, oh, and then I put not today. We're not going to do the annex, the decimal, and the 0. We're not doing that today. Basically, what you're going to do today is multiply, get the leftovers, and make a fraction. This is what we're doing today. Then you check your division with multiplication, 3/4 for each piece, which this is the answer. 4 times, 3, 6, 9, 12, 12/4, divide that and get 3. Then for problem 4, you have 14 gallons of water as your whole. 3 fish tanks. How much in 1? You can also, once you know how much water is in 1, we figured it out, 4 2/3, I could figure out how much is in 2. So once you know the amount of 1, you can figure out the amount of any, okay? So 14 gallons of water, 3 fish tanks. Here's the whole. Here are the pieces. 14 divided by 3. 14 goes in the middle. Do the division. Stop when you get the remainder, when you are at the ones place, and put your remainder in a fraction. Do your checking. 4 2/3 3 times. Add them up. Hopefully you get the whole. If you didn't, you got to go back because there's a calculation error somewhere. Okay, those are the warm-up problems. There's also a quick reference to recognizing fractions as decimals as we kind of move that direction. So this is another warm-up activity just to remind you, 1/10 as a fraction is equal to 1/10 as a decimal. 2/10 looks like this here, looks like this here. 3/10, 3/10. 1/100th, again, we have our ones, then tenths and hundredths. 1 is in the hundredths place. 2/100ths, 1 2 places over. 9/100ths is over here. What if you have 13/100ths? It's got to finish in this place. 13 must end in the hundredths place. THS. Okay, it's got to finish there. And so there's a whole bunch more stuff, but we'll get into that later. There's honestly, like, we barely are going to have enough time to get through this whole lesson. So open up your books, page 143. And lesson 4 problem set. Here we go. 3 fun-filled pages of activities. Got to get this done in 30 minutes so we can do it. Draw a tape diagram to solve. Express your answer as a fraction. Show the multiplication sentence to check your answer, which is this, but then you can't actually solve it by multiplying yet, but you can do repeated addition, and everything is done for you here. So again, taking the one that is the whole, dividing it into this many parts. What does one piece equal? It equals 1/3 because I can't divide 1 by 3. It's 0 times. And then check it. Let's move on to the next one. So I have 2 divided by 3. 2 divided by 3. They've got the little fraction bar for you. We need to make a model. The whole is 2. Okay, you can name the whole whatever it says the whole is. This is the whole, so that's what goes on top. This is how many pieces, or how many sections? Okay, 3, just like the top one. So we have 2 divided by 3. The written part that is weird, that I'm not a big fan of, but here it is. Here we have to do it. So 3 units. 3 units is equal to what? This one has 3 units equal to 2. This one is 3 units are equal to 1. This one's equal to 2. So what's 1 unit? And this is where we take the whole and we divide it by the parts. 2 divided by 3, or 2 divided by 3. Okay? And it does get a little bit messy in here. So if you want to create a space for yourself, you can always divide with lines. 2 divided by 3, we're going to have the standard algorithm in this section. Can 3 fit into 2? No. And so when I do this, I get 0, but I have 2 left over, which gives me 2/3 as my remainder. Now I'm going to check. And it's taking, again, your quotient and multiplying by your divisor. So it's 3 times 2/3. But because we aren't ready to proceed with multiplying yet, I'm going to do this and repeatedly add it however many times it says to. 3 times this number. And then I can add them, and this is kind of how the book does it, like just put the equal sign. 2, 4, 6. I'm adding them together, 2 plus 2 plus 2. And then 6 divided by 3 is 2. And so, again, it's like, why are we doing all this? It's just a whole bunch of the same thing over and over and over. It is, honestly. It's just to help you with your math understanding, and the goal is to use tape diagrams to model these fractions as division so that you understand what the concept is. Like, this is a whole, it's being shared, and when I do it this many times, this is the size of each part. Here, kind of cramped myself. It's 7 divided by 5. it up a little bit so you guys can see better. Oops. I don't stop my filming there. All right, 7 divided by 5. And so let's make our model. Now this time my whole is 7. And how many parts? 5. So you have to make more pieces. And I have a total of 5 units. Those are all the pieces, and that equals 7. But I really want to know what 1 unit equals. And so it's 7 divided by 5. And because I don't want to cramp myself too much, I'm going to have this last part here. 1 unit is equal to 7/5, or 7 divided by 5. And then set up your long division in your standard algorithm. So 5 times 1 is 5. Subtract and get 2, and your fractional answer is 2/5. Now I need to check. And the multiplication sentence comes first, 5 times 1 2/5, which we can't do right now, so we're going to do 1 2/5. Yep. 5 times. So smashed. 1 2 3 4 5. There it is, 5 times. Now you add them. 1 2 3 4 5. 2 4 6 8 10. Fifths is on the bottom. That's how many parts we have. 10/5 is equal to 2. So 5 plus 2 is 7. When you get the 7, you want to compare and make sure that's what you started with. And it is, so we are successful and we move on. And next one, 14/5. Okay, make a model. What's the whole? Yes, 14. How many parts? Yes, 5. So we have 5 units, or pieces. Okay, 5 pieces equal 14. But what does 1 unit or 1 piece equal? 14 divided by 5, or 14 divided by 5. 14 divided by 5. So do the division over here. 2, 10, subtract, get 4, 4/5, check, multiply, 2 and 4/5. And then we have to add it. Instead of trying to squeeze it in, I'm just going to do this down below. 2 and 4/5 plus 2 and 4/5 plus 2 and 4/5 plus 2 and 4/5 plus the 5th one, 2 and 4/5. 2, 4, 6, 8, 10 plus 4, 8, 12, 16, 20 over 5. And then this is a little division problem. And there's our answer. Okay, so sorry if that was off the page there a little bit. That's the first one. Very busy, lots of work, but super repetitive. Same thing over and over. Turn the page and we have our, remember this page from yesterday? Super fun activity here with different types of things. Ooh, and I didn't talk about this section yet. Okay, we'll get to it. Let me just show you the example. If this is a division expression, remember an expression does not include the answer. There's no equal sign and there's no answer. That's what an expression is. The expression means just set it up to solve. This is a fraction, of course. Yesterday it said improper, or in lesson 3 it said improper fraction. It may or may not be improper. You just are going to have to decide what it is. And then between which two whole numbers is your answer. So you may not be able to recognize it from here, but you can certainly recognize it from here. If I was to divide 13 by 3, 3 fits into 13 4 times. Okay, so that's where you get this. The 4 is how many whole times you can divide. But there's more. So 4 and more. If there's extra, then the and more is going to bump you up in between which two whole numbers. So the two whole numbers are going to be the lower one and the higher one. So 4 and 1/3 is between 4 and 5. That's what this is all about. So we only have to do that 2 more times down here because this one they're telling you it's actually between 0 and 1. So they gave you the answer, which is very nice. So if it's 6 divided by 7, then the fraction is easy peasy. This is a proper fraction. That's why they don't have improper, because today you can have an answer that's less than 1. So this fraction's value is between 0 and 1. So 6 divided by 7 is 0. And then multiply that and get 0 and have 6 remaining. And then 6/7 is your answer. And we don't have to do any more checking or anything. It's just really more recognizing what is the value of the answer. Okay, move on to C. 55/10 is 55 divided by 10, which is 55 divided by 10. So where am I going to land? Well, do the division first and you'll see it. Divide 55, 10 times 5 is 50, with 5 left over. So if I am here, I'm past 5 and almost to 6. The next one up. So 5 and a half, 5 and 6. Okay, next one. 32/40. 32 divided by 40. It's the same thing, just written differently. 32 divided by 40. Remember, we can divide any size numbers now. Now, is this a proper fraction or improper? Okay, this is a smaller number than this one, so it's a proper fraction. Can 40 fit into 32? No. Therefore, I end up with 32/40. So my answer is again between 0 and 1. I hope that is clear. It's as clear as mud. This is sadness. I don't like this activity. Yes, I know. Now, there are some that are better than others, and this is not my favorite, but they all have some kind of a weird purpose, I suppose. And again, you are just going to be outstanding mathematicians if you can get through all this. If these are helpful, click subscribe and come back again. Let's move on. Number 3. Greg spent $4 on 5 packs of sports cards. So now a lot of you guys will be like, I don't know how to make the tape diagram. So think about this. How much does he have? Okay, he spent $4. He spent all that money. $4 is divided among the 5 packs of cards. Okay, so $4 was spent on the 5 packs of cards. It's 4 divided by 5. Okay, and so if you want to know how much he spent on each pack, it's 4 divided by 5. And so he spent 4/5 of $1 on each pack. Take your 4 and divide it by 5, and you get your 0, and then 0, and then 4 and 4/5. Now, how much money is that? Sometimes B will say exactly how much money is that. And so you can figure out if you break $1, which is like 100 cents, into 5 parts, you can do it this way. And then you can figure out the size of each part. Remember, I said if you can figure out the size of one, you can figure out the size of any. And so here's where you can figure out the amount of each piece. And so if 20 cents is 1 piece, or 1/5, then it's 4/5. So oh, wait, but these are, it's 4/5, sorry. So instead of getting 20, instead of repeatedly adding this, I'm going to do 20 times 4 to get the 80. Okay, so there's real quick, we have 5 packs. So if it's 80 cents for each one, oops, or a fancy S, 80 cents for each one, again, can't fit them. And then you're going to end up with $4. Okay, so we've got all this back to the $4, 80 cents per pack. Okay, so there are lots of things going on here. This is only for one piece of that, but it's 4/5. 4/5 is 80 cents. Any of these would do because he bought 5 of them. 1, 2, 3, 4, 5. And that gets you back to the $4, which we just proved is the total. Okay, so sorry, that's kind of roundabout, but this is your price per pack. How about, what if Greg spent half as much money? So we got to cut this down to $2 and bought twice as many packs. So that's going to, instead of being 5 packs, it's 10 packs. So your model is going to be, you can make it a little longer so it's not quite so smashed. $2, and then first cut it in half, and then do 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, so that you have 10 packs of cards, because each of these represents 1 pack, remember. So if I now have 10 units, and that's equal to $2, 1 unit is equal to 2 divided by 10. And again, 2 divided by 10, or 2/10, which can be simplified to 1/5. What's 1/5 of $1? We already figured it out. 1/5 of $1 is 20 cents, which actually should be written this way. And so 20 cents per pack. Okay, so let's move on. 5 pounds of birdseed. Time's getting short here. 5 pounds of birdseed is used to fill 4 identical bird feeders. And, oh yeah, okay, so this one, I always want to just jump right in. I'm like, okay, 5 pounds, divide that by 4. But the first question, I don't know how many years I did this wrong. What fraction of the birdseed will be needed to fill each feeder? Well, on this one, we're taking, if there are 4 feeders, require 1/4 of the seed. Okay, it's the lamest question I've ever seen them set up, because they're not actually asking you to solve it yet. They're just saying, make your tape diagram. And so how much, what fraction will be needed to, well, there's not even a question there. It's just 1/4, because I'm putting it all together. The actual work would be on part B. And how many pounds of birdseed are used to fill each feeder? This is the actual question. So you take your tape diagram and just do it again. 5 pounds, 5 pounds, 5 pounds, 4 feeders. What is this one? And 5. And 5 divided by 4, or 5 divided by 4, 5 divided by 4, 1, 4, subtract and get 1 1/4. And you don't need to go through the whole checking process, but it is 1 1/4. If you wanted to do all the checking, it would be 1 1/4 4 times. But again, you don't have to follow all the steps that you did before. It's just to figure out the units. So 4 units equals 5 pounds. 1 unit equals 5 divided by 4. 1 unit equals 1 1/4 pounds. 1 1/4 pounds. Okay, now finally, how many ounces of bird seed are used to fill 3 bird feeders? So you're going to take your 1 1/4, and you can do this. And this is pounds, LBS, but it's asking about ounces. So you've got a couple of options. You can add up all of your pounds and get 3 3/4 pounds. And then you can convert this because you need to change to ounces. Remember that 1 pound is equal to 16 ounces. That's your conversion equivalent there. If you want to, you can take, because some kids will say, oh, I don't want to add up all this stuff and have so much to multiply by 16. So you could take your 1 1/4 and multiply it by 16 ounces and find out the ounces per pound. So 4 times 1 is 4 plus 1 is 5. And this is a little preview into multiplying. 16 is 16 over 1. And then Crazy Town, I'm going to cross cancel, which you guys are like, what are you talking about? But when we multiply, we're going to be multiplying straight across. But what I'm doing is I'm simplifying it. And so I will teach you how to do that very soon. But I'm simplifying this. I'm using the commutative property to shift this and call this 16/4, and then 16/4 is actually 4. So mathematically it does work out, but it will come soon, and I'm like getting really late with the lesson, so I want to wrap it up. But anyway, 3 3/4, this is for 1. For 1, and then you can do that times 3. And then you get 60 ounces. That's just one way. You could also take 3 3/4 and multiply it by the 16. This is probably a lot easier. So that is the lesson for today. How about that? It's almost 30 minutes. But I hope it was helpful. You guys are so awesome. I will see you soon.